Alright, on the workbench today we have the function signal generator kit from eBay that's based off the XR2206 chip. So let me go open it up and see what this kit comprises. First of all, here's our instructions or part list. There we go. Kind of a very brief instructions and schematic. We've got the case, which is basically made of perspex. That there. Here's the board itself, which I'm going to be soldering. A very simple, small little board. And then we have a couple of components, which I'm just going to lay out nicely now so you can get a quick idea. Those are all the parts that are in this particular kit. Interesting over here, we even have a nice header for the chip, and there's the IC itself. And yeah, that's this entirety of this kit. Right, so this is the board that we're going to build, and I'm going to start putting the components on from the flattest to the tallest. So basically, first of all, I would like to start with all of these resistors. Followed by the capacitors, first the ceramics and then the electrolytics, and then we'll carry on from there. So what I'm going to do is I'm actually going to just check each one of these resistors and just figure out what their actual values are, make sure that they're correct as per the spec, and so I don't get them mixed up. So let's go and switch this thing on and do a quick test. Right, so those are all tested. So if we basically look back at the schematic, you can see over here we will need all of these resistors. We've got a 1K, a 5K, a 330, and then there's a couple more over here. The 5K is just 1, 2, 3, and that seems to be it. Why did they give me so many then? Why did they give me 6 when I only need 3? Maybe a couple of those are spares, or I'll get to them as we go along. Great, so yeah, I'm going to start soldering these into place as per this spec. Right, and those are all the resistors that I can actually discover on this board. I still don't know why I've got these 3 spare, but that's alright. I'll just put those aside. And now I'm going to turn my attention to these ceramic capacitors. These are all very clearly marked. You can see 101, 104, 104, 105. What's that? 22, 222 and 473. Should be able to just see that. So yeah, these can go in any direction. I'm going to put them in now as well. You can see here on the schematic, I tell exactly where they go. So here we've got these they just call them non-polar capacitors. So we've got them here in positions number C2, C5 for the 105, C6, C7 and C8. So I'm going to go and install those now. And with that, it looks like all the what they call non-polar, so ceramic capacitors are installed. So once again, I have one of them that's spare, one of these 104s, which is interesting. I just needed the one. So I'm going to put that one aside. And now I'm going to shift my attention to the electrolytic caps. There's just the 3 of them, and they of course are clearly labeled as well. The thing with the electrolytics, of course, is that we need to make sure we put these on here in the correct order. So C1 is the, well, let's just see what they are first. This one over here, as you can see, is the 100 microfarad 16 volts. This over here is a 25 volt 10 microfarad, so it's small, I'll put it on that side. And this is another 25 volt 10 microfarad. So the first one over here is this 100 microfarad, and that's the one that goes here into this position C1. Now you can see over here that they have this shaded area over here, and they have this non-shaded area over here. I'm not exactly sure what that means. I assume that the shaded area means that that is the positive. Let me see if they say on this board. All right, if we look at the schematic, we can clearly see capacitor 1 on the positive side, the incoming current, which goes to capacitor 1, and it also goes to VCC here on JK1, where 2 and 3 are grounded together. So if we look at this board, it's not that clear from this side, but here we can see that the top pin, which is this one here, going through from capacitor 1, is going through to this pin, whereas these 2 over here are joined together and thereby grounded. And similarly, the bottom pin is also from the capacitor, also goes through to this same combination over here, which is grounded, which is basically the negative side of capacitor 1 going through to ground. So that confirms that the shaded area is indeed the negative. That's the positive. So that's where the longer lead must go. So let's go ahead and do that. All right, and there we have done all the electrolytic capacitors for this board. The next thing I'm going to do is insert the IC socket into this center pin, which is this IC socket over here. Notice, of course, that there's a notch at the top which you can line up. I guess with a socket like this, doesn't really matter, it would go either way. But this is good for when you cover up this hole, of course, that you can see when you put the IC in where the notch is. So that actually sits in there quite nice and tightly. And I'm going to go ahead and solder that in. I'll just do the first 2 opposite pins first. Maybe twist it a little bit that way. And in fact, just to be absolutely sure, I'm going to use my good friend, trusty piece of tape, which I like to stick onto my boards just as a kind of a helping hand to hold these in place. Usually works pretty great. There we go. Let me start soldering that now. Right, that's worked quite nicely. I think at this point I'm going to go ahead and install the IC. Here's where I need to line up that pin over here, and so you can see there's the 2206 CP IC. Now you might find over here when you put these in that these pins are a little bit wide, which indeed they are. So you can just kind of squeeze them a little bit against the table just to kind of straighten it out ever so slightly. A little on that side, a little on this side. All right, and the ICE is installed. Now we're going to do some of these terminals. So a couple of things we need to do is the power terminal, and of course the signal terminal post, which is going to be connected over here to the outside. And then afterwards we've got to do some pin headers, some for these jumpers and some for those jumpers over there. So once again, let's see which of these is the tallest. This one over here is the smallest, so we'll start with that one first. These are going into the case so that you can access them from the outside. So you can see over here, there's a nice opening over there. And I'm going to use my trusty friend tape once again. All right, those components are all on. The only remaining thing that still needs to be done is basically our 3 pots in these positions over here. Then I believe that this kit, the board itself, actually is indeed then complete. There's 2 styles of resistor here. You can see this one says B104, and both of these on the back say, get them into the camera, clearly say B503. Those go into certain positions. You can see over here, the B503 goes into positions R3 as well as R2, there they are, whereas R8 gets this B104, just to make sure we put the right ones in the right places. So I'll start with the B104. I'm going to put that into the correct position, which of course here is R8. And with that, this board is now complete. So now we can actually go and install this board into this case. So we'll need this and some of these screws over here. We're going to open this up and see what we have. Four longer screws, 4 shorter screws, and only 4 nuts. Interesting. Let me open up my case pieces. Even though they look brown, they're not really brown. What's going on here is that this is clear perspex, so it just has a label pasted to it. So there's one side, 2 of the short sides, 2 of the long sides, the bottom, and the top. And the top is even nicely printed over here for the various functions of the signal generator, which you can see right there. Fantastic. And there we even get our signals going out. Just going to be, so this sits right there like this. And this is the bottom. Like that. And then this needs to have the board mounted in over here. And this piece over there. All right, well, let's go ahead and start assembling that. Right, I'm going to start by putting these short screws here into this board for a little bit of height. So basically put them in and put these nuts on. And now I'm going to start assembling this. Well, taking all this brown covering off, and here some more, has taken an absolute age. So now let me start again with the assembly of this into the case. So we've got these screws on here, that goes into there. You'll notice the left and right side are slightly different. This cutout is larger, which is for this over here. This cutout is smaller for that over there. So we can just go and slot everything in. And that seems to be all the pieces held together. Now I'm just going to drop some screws in so we can get this thing to hold. And last but not least, I can put on the knobs and the jumpers into the positions that we want. So you can see this jumper over here picks between triangle and square and sine wave, sorry. Let's put that into sine. And this one does the frequency. I'm just going to put this right in the middle so it looks pretty. And let's see, these sweep from this position, which is approximately the 8 o'clock position, all the way around to that position, which is about the 4 o'clock position. So this does indeed point to where it's pointing. So we could just go ahead and put these guys on kind of in the same manner. Amplitude, fine, and coarse. They sweep all the way around. And with that, we've built the entire function generator kit. You can see over here, here's the power input, 9-volt center positive. And on this side is where our outgoing signal comes, either common ground, we have a square wave, or sine or tri, depending on the position of this jumper. Even though it's sending sine or tri based on this, I believe it's always sending out the square wave as well. But I believe there's some of these settings here that are not applicable to the square wave. But I think it's time now to actually give this a good test and see how it works. Right, let's test this function generator. So I've got this DSO shell oscilloscope, which is also a $25 kit from eBay, which I've built in another video. In fact, if you'd like to see, click up here and you should be able to see the video of me building that kit. And I'm going to use that to be able to show you what's happening on this board. So first I'm going to connect up ground, and then to start off with, let's take the sine and the triangle waves. You'll see also I've taken 3 jumper pins, wires which I've just wired in over here, so we can connect this up. There we go, to this board. And then also coming from my bench power, which is probably that noise here in the background, I've got 9 volts, which I'm going to go plug in now to this board. And there we go, you can see it's set to triangle, currently in the 100 to 3 kilohertz range. And there immediately on this display we get a beautiful triangle wave. I can go and play with this a little bit, so let's just leave this here. Play with this amplitude, you can see there it even starts to clip as the top of that triangle wave starts to flatten out. Then we've got our coarse and our fine. Coarse over here, of course, is increasing or decreasing the frequency. And fine does the same thing, but just in a very, very finer manner. That's not bad looking for a triangle wave. Let's go and flip this thing across to the sine wave. And yep, that's not looking too bad there. Also, when I turn up the amplitude, you can see how it clips at the top. But there it's not clipping. This is quite a gorgeous wave over here. Maybe I can turn the scale up a little bit and move this thing down. And let's adjust this trigger a little bit. Just so we can catch this wave. There we go. And play with this some more. And the sine wave, oh, this is not looking too bad. Turn this amplitude down, now we're losing it. See if we can catch this wave again. There we go. Very nice. Of course, we don't know the absolute positions because everything is just relative. Right, let me switch on to the square wave. I'm swapping over to the other pin, the other signal. Whoa, and there we go. Turn this thing down a little bit. And there we go, and let's catch this. And there we have it. A little bit of background noise, but I actually think that noise is coming from my lights that I've got here in my recording setup, more so than what it's coming from this device over here. Now what's interesting is that you'll notice you cannot adjust the amplitude at all, but what you can do is you can adjust the frequency. So I can increase the frequency of the sine wave or slow that thing right down. Right, and then this just changes the jumper for the different ranges of this frequency. But yeah, overall this board seems to be working absolutely great. Well, thank you very much for watching this video, and stay tuned for more similar videos about electronics and audio and anything similar here on YouTube.